Howdy y'all, and welcome back to our course, Databases Demystified, sponsored by Fivetran. I'm your host, Michael Kaminsky. Today is going to be the first part in a three-part series on distributed databases. This is a really important concept in databases and in computing in general. Today we're going to talk about why we need distributed databases and the two major paradigms that distributed databases are used for. In order to get you oriented, I want to talk a little bit about distributed and single-node databases and where you might have encountered these technologies before. Distributed databases are, as their name suggests, made up of multiple computers where the data are distributed across those different computers. That's in contrast with single-node computers, where the entire database runs on a single computer, sometimes called a server. Distributed databases you may have heard of include Google Spanner and Azure Cosmos, as well as all of the big data warehouses like Redshift, Snowflake, and BigQuery. Single-node databases are the classic databases like PostgreSQL, MySQL, SQLite, as well as many others. When we think about why we might need distributed databases, there's a few motivating problems that might lead us down this path. The first is that, for some applications at least, we might have a lot of data that we need to store, way more than can fit on any one computer. Additionally, analyzing all of that data takes a really long time. We want to be able to speed up our queries by using the power of multiple computers at the same time. Finally, resiliency is really important for many applications. We don't want our whole system to go down if our database hardware fails or if there's a network error. If we have all of our data stored on one computer and that computer goes down for any reason, that's going to cause us real problems. The first question that you might ask yourself when you're facing the problems of having too much data or needing to speed up your queries is, can't we just use bigger and better computers? And that's definitely a good option, up to a certain point. A lot of people working with PostgreSQL or MySQL databases, for example, will upgrade the underlying hardware for that database for a while before needing to switch to a distributed database, if they ever need to switch at all. However, there are a few things to keep in mind when pursuing that path. First, big computers are generally really expensive. The bigger the computer is, the more expensive it's going to be, and that scales non-linearly. So a computer that has 128 CPUs is going to be much more expensive than 16 computers that have 8 CPUs each, even though that's the same number of total CPUs. Computers get disproportionately more expensive as you make them bigger and bigger. Second, there's a limit to how big anyone can make a single computer. At some point, you'll reach a level where you just simply can't buy a computer that's bigger than the one that you currently have. Finally, as you might have gathered from the 2 points above, the more specialized your hardware is, the more likely it is to break. Specialized hardware is more fragile, has more moving parts, and is more difficult to replace, so increasing the size of our computers exposes us to more risk of a breakdown. A big concept for us as we talk about distributed computing is fault tolerance. If our database is all on one computer and that computer goes down, then our app will go down for all of our users. So if our users are all over the world and they're all connected to our centralized database, if that database goes down, then our service goes out for everyone. This is a real problem for us. If we have an application or a system that's mission critical or business critical, we don't want the whole system to be taken down if and when there are small breakages, or the power goes out in our data center, or a disk fails on one of our computers. All of those things happen regularly. If those minor glitches will take down our business, that's going to be a real problem for us. So that's a thing that we really want to avoid. And that brings us to distributed databases. With a distributed database, our database is actually made up of multiple, relatively smaller computers that act together as one. So they act together like one database, but really there's multiple computers under the hood. If one computer in our database goes down, our database can continue functioning. Not only can we deal with more data this way, but we also get improved fault tolerance. Some terminology here that's really important. In general, when we're talking about a distributed database that's made up of multiple different computers, we're going to be talking about a cluster. So if you see the words database cluster, it normally means that there are multiple computers underlying that database. Instead of saying the word computer, in general we use the term node to describe the individual computing machines that make up the distributed database cluster. So if we have a cluster that's made up of 4 nodes, what that really means is that there's one database that's made up of 4 individual computers that are going to be networked together and acting as one. So you'll see this terminology a lot if you read marketing materials or documentation about distributed databases. Let's talk a little bit about the two big paradigms of distributed databases. The first is big compute databases, and the second is high availability databases. In the big compute databases, we're going to split or shard the data across different nodes, and each node is going to execute the query against a subset of the data. Then we're going to combine all of the results at the end, and that's going to allow us to process our data faster by having multiple computers doing the work rather than having only one computer that has to do all of the work. In high availability databases, we're going to make redundant copies of the data on different nodes. So the whole idea of high availability is that it's really fault tolerant. If one node breaks or falls out of contact with the rest of the nodes, queries can still complete and our users can still use our system. This is going to reduce our dependence on any one piece of hardware. So to start off, we're going to talk about big compute databases. Here's a simplified example where we're going to take this dataset that we have and split or shard the data evenly across the 3 nodes that we have in our cluster. So each node in our cluster has 1/3 of the data in our table. So this is what you can imagine the data might look like on the different nodes. We're going to have 1/3 of the data on node 1, another third of the data on node 2, and the final third on node 3. You'll notice that the data don't overlap at all, so the data on each node are distinct. In the ideal case, the data will be divided evenly across our 3 nodes, even though that isn't strictly required in practice. So here's how this query will be processed by our distributed database cluster. Here we have a query where we're going to get the count of users in each state in our table. What the distributed database is going to do is it's going to send that query to each of the different nodes, and it's going to get the count of the users in each state for the data that is on that node. We're going to get the results of that query for each node, which you can see here, where we have 3 tables of intermediate results. Then we're going to bring those results all back together and summarize them at the end. So the idea is that by splitting up this query across these 3 nodes, we can actually get results back 3 times as fast as we would if there was only one computer that was trying to process the whole query in series. So by splitting up the query and the processing and running it in parallel, we can get meaningful gains in query performance. High availability databases are different. The idea isn't to process really large amounts of data quickly, but rather to be extremely fault tolerant. There are a whole bunch of ways that high availability databases work. We're going to cover the simplest way to think about it in this lesson, and we'll cover more advanced topics in future lessons. So here we're going to put a full copy of all of the data on each node in our cluster. So here you can see what this looks like. You'll notice that unlike in the big compute databases, here the data aren't different across the different nodes. Each node has a full copy of the data. So here we can see that if our application needs to select data from the database, even if 2 of our 3 nodes are down, maybe one is down due to a hard disk failure, maybe the second is inaccessible due to a network outage, the query can still complete because the database knows that there is a 3rd computer available that has all of the data that it needs on it. So let's summarize the difference between these 2 different paradigms. In the big compute paradigm, we're going to be crunching lots of data. We're going to be handling analytical workloads. If you've worked with the Redshift, BigQuery, Snowflake, or any of the MapReduce family of tools, then you've worked with big compute distributed databases. In the high availability paradigm, we're going to be working with mission-critical databases and applications, systems that can't go down. Some existing tools that you might have heard of include Google Spanner or Azure Cosmos, along with many others. So in summary, distributed databases are going to allow us to store more data and scale horizontally instead of vertically by adding more smaller computers instead of continually increasing the size of one big computer. Distributed databases allow us to perform queries over large amounts of data much faster because we can run the job in parallel across multiple different smaller computers. And finally, distributed databases make our system more resilient by increasing fault tolerance in the case of hardware or network failures. And that's all for today. If you've learned something, please leave a note in the comments. And don't forget to like this video and subscribe to our channel. We've got a lot more great lessons coming. And make sure you tune in to our next lesson where we'll cover some of the unique problems that go along with distributed databases. Stay safe, and we'll see you in the next one.